class. Welcome to lesson 1.6, line of best fit. Before we get into that, ladies and gentlemen, we're going to do our warm-ups. So here's a quick refresher of last day's lesson. The question says, for number 1, determine the equation of the line, which is in y equals mx plus b form. So for example A, our relation, or in this case function, is represented by a table of values. And in order to give me the equation of the line, you have to sub in two things, the m and the b. Looking at the table in A, ladies and gentlemen, you should notice that it is easy to identify the b variable first. Okay, so the b variable is right here where x is 0, so you tell me b equals 3. And then, ladies and gentlemen, if we want to find the slope, ladies and gentlemen, is, depending on what formula you want to use, I'm going to do the first differences. So I'm going to do the change in y's. Remember, it's the bottom subtract the top. So it's going to be 9 subtract 7 is 2, 7 subtract 5 is 2. And you'll notice that it's got the same pattern. Don't forget to do the change in x's. Okay, so to figure out the slope, ladies and gentlemen, the slope equals, in this formula, I'm going to use change in y over change in x. I sub in my values. It's going to be 2 over 1, which tells me slope equals 2. I've got my m value. I've got my b value. So therefore, y equals 2x plus 3. There's the equation when given a table of values. Example B, ladies and gentlemen, pretend there's some nice lovely arrows on there, has a graph of a straight line, okay? And what we need to do is, again, find the m and the b. Looking at my graph, notice that it hits the y-axis at 1, so that tells me that b equals 1. Now, ladies and gentlemen, in order to do the slope, you could do it a couple ways. You could use y2 subtract y1 over x2 subtract x1 from those 2 points. So I'll show you that. That's one method of doing it. Okay, and when you do the substitution, ladies and gentlemen, y2 in this case would be -1, subtract 3 over x2, which is 1, subtract a negative. When you subtract a negative, it really becomes a plus. So you'll end up here with -4 over 2, which equals m equals -2. Or, ladies and gentlemen, you can join 2 points on the grid here. So here's 1 point. I'm going to choose a smaller point here. I'm going to use this triangle. You also, ladies and gentlemen, could have used this triangle, and the answer will simplify out the same. So in this case, when I'm using my smaller triangle, notice as I go left to right, I'm going down. So that means -2 spots and 1. So in this case, my slope and my formula I'm going to use is rise over run. So in this case, it's -2 over 1, so slope equals -2. Since we've got the slope, we've got the b value, we can sub it in. So therefore, y equals -2x plus 1. And there's your equation for that one. And ladies and gentlemen, part C. Taking a look at part C, folks, we know it's a linear relation because there are no visible exponents. However, we want to get it in the form y equals mx plus b. So let's get that y term, or the term that has the y in it by itself. So I'm going to leave the -2y on the left side. And I'm going to move the 3x over to the right side, and it's going to become -3x plus 24. Okay, getting close, ladies and gentlemen. To get y by itself, currently it's multiplied by -2, so you need to do the opposite, which is divide by -2. Whatever you do one term, you do the same to all the terms, so you'll end up here with y equals -3 divided by -2. The negative divided by the negative gives you a positive, and you'll have 3 over 2x. A positive divided by negative is subtract 12, okay? And there's your equation for C. All right, little pop question from what buttons we're going to press from last day's activity. Okay, to enter the data, ladies and gentlemen, what buttons do we use? Well, to get those lists, which had L1, L2, L3, you press the Stat button and enter, or 1, which is edit, doesn't matter. Enter is just easier. Okay. And then to access the settings, so the X max, the X min, the Y max, the Y min, that's when you press the window button. That's to get your screen to show all your data in it. Okay. And then for C, selecting the graph type, that's your stat plot, which is second y equals and enter. Okay. And what button do you press to enter the equation? That is just y equals. These buttons are going to be helpful to remember today when we do some activities. So today's lesson, ladies and gentlemen, is the line of best fit, and today we're going to use the graphing calculator to help us with that. Okay? So let's take a look here. The lesson title is 1.6, From Data to Equation, Calculating the Line of Best Fit. And folks, you should know this definition. The line of best fit is a line that passes as closely as possible to all of the data points, or all the data. You probably want to bubble this and make sure that you know how to do this. The line should have equal values above and below the line, and the slope should follow the trend of the data. For example, in this graph, ladies and gentlemen, if I put a line through here, you'll notice that there's roughly the same amount of data on the left and the same amount of data on the right. However, my blue line, is nowhere with the trend of the data. So the best thing to do is to grab a straight edge. I'll just exaggerate it by using this. Grab a straight edge, or pencil, ladies and gentlemen, and cover up as many dots as you can like that. Okay? And you can select, or use your ruler is a great idea, especially if you got a see-through one. Okay? And look from left and kind of shift it on the diagonal to see where you can get most of the dots covered. Okay? And then draw a line in the middle of that. All right? So that's what you're looking for. Just remember, folks, if you decide to do something like this, and oh yeah, I've got equal dots on the left and the right, then guess what? You're not getting the general trend of the data. So first, line it up so you've got the trend, then try, then try to see if you can get, I'm going to shift that down a little bit more of an angle there. Then shift to see if you can get most of the data on there. All right, I'll just move that off to the side and maybe delete it because we don't need it. Okay, perfect. All right, so ladies and gentlemen, once you have accurately drawn the line of best fit, we can determine the equation by finding the slope and the y-intercept. Today's lesson, ladies and gentlemen, we'll be using the graphing calculator, and it will do what's called a linear regression. It will find that equation for us. However, next day's lesson, ladies and gentlemen, you can envision yourself drawing this by hand, so make sure you got some graph paper, a straight edge, and a pencil, and you're going to pick 2 points that are on the crosshairs. And from that, ladies and gentlemen, you can create the slope. So you find the slope, and then you sub the slope in and a point to find your B value. All right? But for today, we get the technology. And again, you can find any of this technology on the website, free apps that can be on your phone or on your tablet or iPad. Okay? So taking a look here, the graphing calculator has functions to create the line of best fit. It can provide us with the equation. So if, ladies and gentlemen, yesterday you started your own sheet with graphing calculator buttons, you may want to place this at the front of your notebook, and you keep all your graphing calculator instructions together. So that's what that means, folks, if you want to place this box in front of the notebook. So that would be on your calculator button sheet. Okay? If not, you might want to start one with this. Okay? And you want to write this box in exactly as it is. 2 key things to remember. Number 1, before we do any of the inputting of the data, we have to turn the diagnostics on, and we'll use these buttons and follow that through. Then we will do what we did last day, like enter the data, set up the graph. Then the new thing today will be number 4. We will perform a linear regression, and I will tell you how to do that. Okay? So you do this box, folks, in a separate sheet of paper, and maybe identify it as graphing calculator buttons and join it with the one you did last day. Then you come back to our note, and we're going to take a look about another aspect that the graphing calculator does. Instead of just giving the line of best fit, it says how closely the data fit together. So for example, if I just show a little graph here, guys, we could have data points going like this, and you could see hopefully there's an upward trend. Okay? Likewise, if I show you another upward trend that looks like this, ladies and gentlemen, Notice that the red graph, the data is closer together, so it would have what's called a stronger correlation than the green one. The green one still has a pretty strong trend, but not as strong, meaning the data points, if it's very strong, are going to be close together. And that's what we do with the graphing calculator, and that's called the correlation coefficient. So we're going to set up, and it's going to give us what we call an R value. And the R value is going to be the correlation coefficient, how tight each data point fits close to the line of best fit. So basically, the graphing calculator does a lot of calculations. It'll perform a straight line, then it'll take each data point and say, hey, what's the horizontal displacement and the vertical displacement for each data point? And there's probably going to be some that are going to be above it, ladies and gentlemen. So it'll calculate everything below, the displacement below and beside it. Okay, and that comes up with the correlation. The tighter the data points are together in a trend, the closer the R value will be to +1 or -1. So this sign, folks, I don't want it to confuse you. This says closer to + or -1. The positive means the sign, ladies and gentlemen, of the R value tells us if it's a positive trend, it's going to be positive. Negative means it's a negative trend. Okay, the value, however, meaning the numerical value of R, tells us the correlation strength. Okay, the closer to 1 or -1, the stronger the correlation. So here are some examples, ladies and gentlemen. The R values will make sense in a couple minutes when I show you an example. Okay, but R in the first example, first of all, is it positive? Yes. So I'm going to write positive down. Second one, R equals -1.0. That is negative trend, so it's going to be going down. Oh boy, negative. Let's try that again. Okay, R value of 0.72, that's positive. Okay, and R equals 0.54, that's positive. Okay, so first of all, we've got the sign. That tells us what direction the trend's going. And then we got to think about 0.8 is roughly 80%. That's pretty good, right? So that would be a strong correlation. Okay, so this would be called a positive, strong correlation. So that would kind of look like this example here in the red, very close together. Okay, now negative, the second one, it's negative, but 1 is the absolute closest you can get. So 1 is a perfect correlation. So this is actually called a negative perfect correlation. What does that mean? That means all the data points fit on a straight line because it's a linear regression. Therefore, that means this is actually a linear line or a linear function. So what that would look like, folks, is if I drew all my points and I drew the line of best fit. Let's see if I can do this accurately here and see how they would all fit on the right line. That's a positive correlation that I had there, folks. Okay. All right. Let's look at the next one. R equals 0.72, 70%. That's a good, so a positive good correlation. Okay, and then a 0.54, well, that's pretty weak of a correlation. It's going to be spread out. So you can gently see a trend, so it might be something like that. See how you can tell it's a downward trend, but it's hard because they're spaced out all over the place? Okay. All right, so to finish today's lesson, we're going to be going on the calculators. So please, in your textbooks, follow along because I'm going to need your help on page 42 and 43 because the instructions are written down there. I will tell you I'm going to make an adjustment to this homework. It's going to be page 46, numbers 4 and 6. Save 5 for next class, okay? So just 4 and 6. All right. So ladies and gentlemen, I'm going to pop up the graphing calculator on my screen, and you can just go to any online calculator that has a data input, or maybe you, even after doing your research yesterday, were able to download this for free. Okay? And maybe you've got that figured out already. Okay? So we can use this. If not, make sure you turn to page 42 and follow along in the instructions. So in the investigation here on page 42, it says a 1998 newspaper article contained a graph similar to this. The graph shows how olive oil imports in Canada increased from 1986 to 1996. You can use this information on your graph to predict the olive oil imports for other years. So first thing it says to make a scatter plot, but what you want to do is reset your calculator. So let's just do those buttons quickly. You can see when I press the history, you can see. So I'm going to go second function plus sign 722, and that's going to say default set. That's going to reset all my programs. Then I'm going to clear my list. So second function plus sign 4 enter. It says clear list are done. I'm going to go y equals, make sure I have no equations in there. And then I want to go to mode, and today I want to leave it at float, okay? It'll just be easier for me to enter my data in, so make sure float is highlighted like it is. And if you've reset your calculator correctly, it'll look like that. Okay. Now what we're going to do is follow what it says. So I'm just following, reading along on page 42 where it says make a scatter plot. So 1A, to enter the data, press stat and 1. Okay, so you'll see your list. They should be emptied. Okay, then it says enter the years in. So we've got 1986. Just so you know, my graphing calculator is working much better today than last lesson. I apologize for the delays and the errors that caused. That was frustrating me, but today it is much more cooperative. Okay, so I'm just entering in the years that they've asked me to. You can also see them on the chart in the bottom of the bars. I have them there. Okay, so that's the first one. The next step, ladies and gentlemen, it says to enter the corresponding olive oil imports in thousands of tons. So be careful here. Do you see the first bar, folks, under 1986? It says 5.7, but that's thousands of tons. So it's going to be 5,700. Enter. Okay, do the next one. 7.9, 7,900. Okay, we perform the next one. 10,100. Okay, and then 13,800, 14,900, and 19,000. Okay? And taking a look here, ladies and gentlemen, I've got to make sure that I've got everything matched up. Something looks like I'm missing. 1986, 1988, 90. Look what I did. I missed 1992. So watch what I'm going to do, folks. So I'm going to go over where 1992 should be, which is in there. I'm going to insert and add it in. So 1992. There we go. Now you notice my data matches in the L1 and the L2. And now we can do part B. So 1B says to set the scatter plot by pressing second y equals. Second y equals, you got to turn the plots on. So you press enter. And you want to make sure, ladies and gentlemen, that it says L1 and L2. So we're going to go second 1, if it doesn't say that already, and second 2. Enter. Okay? That's where we've entered our data in. Okay? And then, guys, just for kicks and giggles, why don't we press graph? So we press graph. That's our standard window, -10 to 10 on both the X and Y axes. That's not going to show any of our data. So you got to press window and think carefully. What did we put in L1? That was our years. So why don't we, since it started at 1996, why don't we put 1992 in? Or sorry, 1980, because it started at 86. So let's go 1980. Okay, enter. Maximum, let's make it 2010, just so that we can do some predictions if we want to. And we'll use a scale of 10. Okay. The Y minimum, ladies and gentlemen, you can have 0 for your tons of olive oil, but be careful here. There's an error in the textbook. The textbook just has an error of 30. But, ladies and gentlemen, we want to go 30,000 because they forgot to put in the thousands. Likewise, when we go down to the scale instead of 5, we're going to go 5,000 for our scale. So please make sure you fix that up. Okay, and the resolution stays as 1. Now we're going to press graph, ladies and gentlemen, and you'll see your 6 data points. They look like they're a trend, ladies and gentlemen. What type of trend would that be? Hopefully you see upward trend. And do the data points look like they're in a clear line together? Yeah, they're pretty close. So this is going to be a very strong correlation. Okay, so now we're on, ladies and gentlemen, to the top of page 43, graphing the line of best fit. So what we're going to do is perform this linear regression. So for 2A, it says to press stat. Stat's this button right here near the arrows. And then press the arrow over button, which is called calculate. Okay, so it gets the calculate menu. We look for linear regression, which is number 4. And so what that tells the computer that we want to do a linear regression or get a line of best fit, but we got to tell them where to get the data from. So we're going to make sure we know that we got them from L1 and L2. So you see in the next line it says to press second 1, comma, second 2. That tells us we want to get the data from list 1 and list 2. We're going to press another comma, and we're also going to get it to come up with the equation in y equals for us. Okay, so to do that we got to press some other buttons, and we got to go to the vars. And we got to go over to y-vars because we want it in the y-axis. We want it to be a function, and we want it to go in our y equals screen where it's y1. So hopefully it looks like that, ladies and gentlemen. Then you press enter, and you'll notice that we've got our line of best fit right there. And if I press y equals, we've got our equation right there. If I press graph, we've got that value right there. Now the one thing we do need to do is if we want to deal with that R value, which I'm going to do, and I know it's not part of this page right now, we're going to have to turn the diagnostics on. So go back to your lesson for those steps where we just wrote down the graphing calculator buttons. And to turn the diagnostics on, we have to find the catalog, which is second and 0. So see the catalog, scroll all the way down to diagnostics on. I know it's way, way down there. There's a lot of things in the catalog. Getting close. There's a diagnostics on and off, so you need to have the right one. So see how the arrows at diagnostics on, hit enter, but we're not there yet. We got to press enter and done. Okay, so now we're going to do that linear regression one more time. And the R value will show up, and it'll tell us how strong a correlation we have. So I'm going to do that regression again. So I'm going to go stat, over to calc. My linear regression is 4. I'm going to tell it where its data is, second 1, which is L1, comma, second 2, which is in L2, comma. I want that equation to come up where the vars is, so I'm going to go vars, over to y-vars, hit enter. I want it in y1. Press enter. And now, ladies and gentlemen, know your R value. I'll highlight it up here. See this R value right here, ladies and gentlemen? 0.99. That's very, very strong correlation. So that is going to tell you that, first of all, it's positive and it's very, very strong. Just give me 1 second. I'm going to pause. Hi folks, I'm back because Miss Bear Smith wanted to talk to me. Anyway, so ladies and gentlemen, we just finished with the R value. That tells us that it's 0.99. Let's just look at the graph again. Look how tight the graph is. Just remove that. It looks like there's only one data point that's slightly off, which might be that one. Okay, it's a little bit lower than the rest in the trend. But other than that, guys, that's a very, very strong correlation. If you choose to take grade 12 data management, we take a look at this in detail. And we take it further into solving real life problems. Okay, so ladies and gentlemen, back to our lesson. Remember, your homework today is page 46, numbers 4 and 6. You'll need graph paper, and you can take a piece of graph paper and flip it into half. If you don't have any graph paper, just Google graph paper online, images, and you'll be able to download one or print one off, no problem. Have a great day, ladies and gentlemen. And tomorrow's lesson, or next day's lesson, we'll be learning to do this without the technology. So we'll be coming up with the equation without the technology. And if you forgot, ladies and gentlemen, just so I can go over this, what the equation was, if you're wondering what it was, our equation was, for this relationship, y equals 1302.9x, I'm just going to round it, minus 2,582,000 88.6 liters. That was your equation, okay? So when you deal with real numbers, it's not like y equals 3x plus 5. When you're dealing with real life situations, your numbers are going to be bigger, and quite often they'll have decimals in them. All right, so that was the equation that you should have gotten for that exercise. All right, so back to your homework, guys. Page 46, numbers 4 and 6. Have a great day, folks, and see me if you need some help. Please, by all means, come and grab a calculator in class next day, try this stuff out, and get familiar with it.